So what are the top 5 projects for cybersecurity that you can build right now at home on your computer with Python? So if you're looking to build out your knowledge within cybersecurity, or you're looking to bolster your Python knowledge, or maybe you're looking to learn both, or maybe you're a student and you've decided today that you're going to study Python, this is probably a good video for you to start with, because it's going to give you an overview of some projects that you can build, expand upon, and just a real good base foundational knowledge. So let's get started. We've got our empty file here. It's called python-passgen, and then we've got our actual script here. We're going to take it over bit by bit and build it together. So the first part we need are these 2 import statements. These import statements are going to give us the functionality that we need to do to create this password. So the first one is random, and that's basically a dice roll function that's going to give us the ability to create a random output given inputs. We then have string, and again you're probably thinking, well, doesn't Python have the ability to work with strings already? And the answer is yes, it does, but not to the degree that we need. Remember, a string in Python is just an array of bytes representing some Unicode. So the more we can mess with them and the more we can add a layer of functionality to them that is going to give us a little bit more complexity when creating a password, that can only be a good thing, right? So this string library is going to give us that ability to do that. Now we can go and grab the bulk of the script here, which is just our one and only function for this script. It's a pretty short script, but it does get kind of complicated within it, and we can make it really as complicated as we want, depending on how complicated we want that password to be. So we're calling this function generate password. We're passing in a parameter called length, and we're setting a data type integer, and we're setting it a default to 10. Now this little bit here is known as optional type hinting, and it's basically saying that down within the script we're going to expect something to change the length of what we expect the password to be, but if that argument isn't passed in, just give it a default value of 10. We're then setting a variable called alphabet on line 5, and we're concatenating 3 string statements together. So using the string library that we spoke about earlier, we can effectively create a huge list of all the ASCII letters, all the digits, and all the punctuation on a US or UK keyboard, and then we can store them in the script's memory. We then come down to the password and we say password equals, we set a blank statement and we join and then use the random library that we spoke about earlier. And it's going to say, I want you to choose from this big, huge, long variable of all the ASCII characters, all the digits, and all the punctuation for however many characters we've set the length to be, which in our case is 10. I want you to create a new string out of that called password, and then we're going to return the password. Now it's a little bit complicated, but you'll kind of see what I mean when we import it and print it at the end. Finally, we need to do the printing. So we can take these last 2 lines here and pop them into our script, and just shift this back a little bit. So we're setting a new variable and we're saying, I want this variable to be the output of generate password. And then we are setting our print statement. So we're giving a little bit of text to the user, and then we're asking it to pass in that new variable, which we've set the output of generate password. So hopefully it will be print generated password and then actually the generated password. So I'll just move this a little bit so you can see. And then I'll move this up a little bit. And with any luck, if we run Python, save this first, Python passman, oh, not passman, passgen.py, it'll say command not found, because I always misspell Python. There we go, and it's given us a generated password. This was a pretty basic project you could do if you're just getting into Python or just getting into cybersecurity. It's kind of one of the textbook Python 101 things that you might find in any sort of Python book, just a simple password generator. It's going to teach you about importing libraries like the string and the random one. So let's get started. We've got this empty Python file here in Visual Studio Code, which I've just called python-passman. Then we've got the entire script pre-built here, and we're going to bring it into this empty file section by section, explaining it as we go. Believe me, it's a much quicker way than watching me type. So, first part of it, we've got the 2 import statements, which are going to give us the functionality to encrypt our string and then hide our string, which is our password and our username in this case. We've then got a password manager empty dictionary, and this is going to be used to store the key value pairs of the username and the password. Just going to extend this a little bit here as well so you can see the code a little bit easier. So the next function we're going to bring in is the create account function. Now this create account function is going to ask the user to enter a username, It's then going to ask them to enter a password. It's then going to use the getPass library to hide that password from the user or anyone else that's looking. It's then going to take the password and use the hashlib library to hash that password using the SHA-256 algorithm. It's then going to store that username and the hash password in this password manager dictionary as a key value pair. It's then going to print account created successfully. The next function we need to grab is this login function. Now this is pretty similar to the create account function. This will sort of make more sense in a moment once we see the third function, but this script is ultimately going to ask the user, do they want to create account or log in? And depending on which one they select, it's going to start with which function first. So it's either going to be a create account or a login. So as I said, it's pretty similar. So it's going to ask the user for a username. It's going to ask the user for their password. But we've then got an if statement that basically says, does the username and this hash password that I've been given match a key value pair in this dictionary that I've got stored here called password manager? So the last thing we need is effectively a menu, a way to pick either function 1 or function 2. So what we're going to do with that is we're going to grab our main function, and I'll explain why it's called main, not login or menu or anything like that in just a second. So this main function is basically a while loop, and a while loop's default state is true until it's given a break statement. So in this case, the while loop is true. So while this is true, I want you to prompt the user for either choice 1 or choice 2 or choice 0, which will break the loop and give them invalid choice. So choice 0 could be anything that isn't 1 or 2. It doesn't have to be 0. The last piece of the puzzle and the last few lines of code that we need are this if main equals main statement. Basically, this is just a way for you to take this whole script and import it into another Python script as a library without needing to reorder your functions. It's basically going to tell Python which order it wants you to run its functions. It's known as a Python idiom, and that's not a perfect explanation, and it does a little bit more than what I've just explained, but in our case, it's just going to order the functions in the way that we want to run them, running this main function here first, as it's the login screen. So if you're still around, hopefully you are, we're now going to run this, and we're just going to hit terminal, new terminal. We're going to make sure our script is saved by hitting Control S on it, and we are then going to open a bash terminal because I hate PowerShell, and we're going to navigate to the desktop, and we are going to run Python. And there we go. You can see it's asking for a choice. So enter 1 to create account or 2 to log in. So we'll do create account, and we'll call our account WJ Pierce. And I'll make my password 1, 2, 3, 4, 5, 6, 7, just for explanation purposes. Obviously, you should never make your password 1, 2, 3, 4, 5, 6, 7. I don't even know if websites will let you do that anymore, to be honest. And then we're going to log in. So we want WJ Pierce. And then we want 1, 2, 3, 4, 5, 6, 7, and it's going to say login successful. Or we can hit 0 to exit, or we can run the script again and we can hit 4 and it's going to say invalid choice. So there we have it, a very rudimentary basic password manager that you can use in your cybersecurity studies or as just a fun little hobbyist project. So line 1, we've got import nmap. The import statement in Python, it's basically used to import modules or libraries, which are sort of like bigger collections of code, and they can provide additional functionality to our script that we're writing. Moving on to line 3, we want to create an instance of the nmap.portscanner class. We can then assign it to the variable nm, so we can call it later on in the script, and this is how we interact with that nmap library with this class. We then need to create 2 more variables on line 5 and 6, one called target and one called options. Options is basically how we want to use nmap. So in this case, we want to use the SV and the SC switches, and SV is going to give us version information about the services that it's found on those ports, and SC basically just means I want to run a standard nmap script, nothing fancy. So next we've got the target, and you've noticed that I've already got an IP address in there. So that IP address is actually the nmap website that they've set up for you to be able to scan to practice using nmap. Remember, if you are going to use nmap, it's active reconnaissance and you do need permissions off the website owner before you scan their domain. Moving on to line 8, we've got nm.scan parentheses target arguments equals options. So this line of code is calling the scan method on an instance of the nmap.portscanner class. So the scan method is basically used to perform the network scan using nmap, and you can see that the scan method takes two arguments, the target IP, which we set earlier, and arguments, which we've made equal to options, which we've already defined as a string that we want to use SV and SC. So finally, from lines 10 to 17, we have this big chunky bit of code. And it's basically just a nested loop structure. So it's going to iterate through the results of the nmap scan. It's then going to print information about each host, protocol, and port that was discovered. So there's two kind of loops going on here, and I'll explain both. So starting with line 10, we've got 4 hosts in nm.allhosts parentheses. So this is what we refer to as the outer loop. This outer loop is going to iterate through the list of hosts returned by the all_host method of the nmap.portscanner instance. So moving on to line 13, this is what's called the inner loop. So for protocol in nm hosts all protocols, it's going to iterate through the list of protocols used by that individual hosts, and this all_protocols method returns a list of protocols, basically TCP, UDP, that were discovered during the host scan. We can then move on to line 16, and this is the innermost loop. So for port state in port info.items. This is going to iterate through the list of ports and their states for the current protocol. So we're using the items method here. So let's go ahead and run that script. So we've got a bash terminal here, and we do Python, and then the name of the script, which is python-nmap.py. Now I'm going to cut out a little bit here because it does take a while. And we can see that it's returned a list of open ports with services running on those ports with information about the version of those services and the protocol used. So we can take that information, copy and paste it into another text editor just because it's a bit easier to examine, not in the terminal. And we can go through it and start to do our proper active reconnaissance at this stage. I think we should pause there, and just before we explain the code, we should actually explain what a Caesar cipher is. Basically, a Caesar cipher is a term used within cryptography for an encryption technique. It was actually invented by Julius Caesar himself to send his private messages. Effectively, what he's doing is he's substituting each plaintext layer for a ciphertext layer. Basically, the plaintext version of B would become Y, the plaintext version of D would become A, and obviously with modern computing, this isn't going to stand up in an encryption world, but you have to remember back in the Roman times only the really wealthy could read and write, so this probably did stand up for a fair amount of time. So starting with line 1, import string, you're probably thinking, why do I need to import string? Doesn't Python already have the functionality to work with strings? Well, yes and no. It has very basic functionality to work with strings. The additional string library, and by importing it, gives us the opportunity to manipulate and kind of contort the way we work with strings on a more complex level, which is what we need if we're going to be doing this cipher. So the first function we're going to look at starts there on line 3, and it's the Caesar encrypt function. It's made up of two variables that we pass in, and it's the message and the key. The message is basically the message that we want to encrypt, and the key is the number of the positions to shift down the alphabet to create the encrypted message. This function basically creates a translation table for the cipher, and then you can use the translate method there on line 8 to encrypt the message. It then takes that message and shifts each individual character 3 to the left down the alphabet to get your encrypted message. Just before we jump onto that second function, let me know down in the comments if you'd rather I went through this code line by line as opposed to block by block. Every time I start to explain a piece of code or a script line by line, or I start to get really into the weeds with a piece of technology, my audience retention does seem to half within the first 30 seconds. So that's an indication to me that people prefer more of a light-hearted, just high-level approach. But if there are people out there that do want me to explain it line by line, I do enjoy making those types of videos, so I could make some of those as well. So jumping onto that second function, which is the Caesar decrypt, we need the encrypted message and we need the key again. So that encrypted message is a variable that we've set in the first function, and we pass that in. We're also again passing that key in. So the function will create again a translation table for the cipher, and it'll use that translation method to decrypt the message, but in reverse this time. So it's pretty much doing the same as the first function, but in reverse, and it's going to return the decrypted message as a result. And move on to the two variables that we've used in both of the above functions. So we've got message, which is a string, and the string of text is going to be encrypted and it's subscribed to WJ Pierce. We've then got the second variable, which is key, and that's an integer, and that's 3, and that's how many letters we want to shift down the alphabet to create that encrypted message. We're almost ready to run that script. All we need to do now is look at lines 24 to 28, and it's really simple, 2 blocks of code here. We're setting a variable called encrypted message. It then calls the Caesar encrypt function with the message and key variables as arguments. It assigns the returned value, which is the encrypted message, to the encrypted message variable. It then prints a string with the encrypted message interloped into it using string formatting. Jumping on down to our bash terminal, we hit ls and we can see that we've got the python-cipher.py project. So we run that by typing Python, then the name of the script, and you can see so we've got encrypted message, which is subscribed to WJ Pierce, but every single letter has been shifted down 3. And then we've got the decrypted message, which is subscribed to WJ Pierce. There we have it. Nutshell, the WHOIS tool is a query and response protocol. It's used for querying large publicly available databases, and these databases contain information of registered users' internet resources, such as domain names or IP address. The protocol then stores and delivers that database content in a format that we can understand. And I often see it get confused for the Lookup tool, but remember they are different tools performing different actions at different stages of the reconnaissance exercise. Speaking of reconnaissance, because of the power of WHOIS, it is usually the first step for any ethical hacker trying to gather as much information about their target as possible. As always, we're going to start off with our blank VS Code file, and I've just created a new Python file here. I've called it python-whois.py. In a separate file, we've got our script, and we're going to take it in bit by bit and build it together. So the first thing we're going to copy over is the import socket library. Now the socket library for Python is great. It's basically going to give us that low-level functionality, those really core networking services that we need our Python script to be able to do. So it's going to give Python an understanding of basic things like HTTP and HTTP requests, what is a port and what is a domain. It's going to let Python basically pull that information and then use it within our WHOIS lookup script. Next, we need to go and grab the function, and this is the only function in this script. Although it's quite a complicated one, it's got quite a lot of information, it is the only function in this script. So we are going to call it WHOIS lookup, and we're going to pass it in a string line argument called domain. We're then setting a variable called s, and we're creating a socket using the socket method, which takes 2 parameters, socket 1, socket 2. Socket 1 is called AFINet, and that basically stands for Address Family Internet. Socket 2 is called socket stream, and that's basically declaring that we want a TCP socket type because we're going to be making a TCP request using this WHOIS functionality. Next, we're going to talk about line 6. So line 6 is going to take the information that we've declared in our variable s, and it's going to use the connect functionality of the socket library, and it's going to connect to this URL here, which is our WHOIS URL, and it's going to connect on port 43. It's then going to send a request, which is basically what we call a query, to the domain, which we will define later, and it's going to encode it as a byte of strings. Moving on to line 8, we are going to set a new variable called response, and this response is basically responsible for receiving, you guessed it, a response from the WHOIS server. And we're going to give it a buffer of 4096, and it's going to decode it into a string so we can actually read it. And then on line 9, we're going to close the socket, and then line 10, we're going to return the response. Now, it gets a little bit kind of convoluted there, but stick with me and I'll go through the response and the output of the script, and you'll, because of the output, be able to see where different functionalities of this function come into play. The last thing we need to grab is the last part of the script, and it's really simple. It's just a print statement. So on line 12, we're going to pop that print statement in, and this print statement basically calls the WHOIS lookup function, which we've defined earlier, and it takes an argument, which in our case is google.com, and then it's going to print that response. So we can print it and go through the output together. So I've got my bash terminal open here, and I'm already navigated to the desktop, and I'm just going to run the script with python space python-whois, which is the name of the script. We hit enter, and it gives us a output of information that we would expect the WHOIS lookup tool to give us. So you can see it's given us information on Google, such as when it's registered, when the domain expires. It's given us a status, and it's saying active, and it's also saying that it's client transfer prohibited, which locks down that domain and prevents anyone else from transferring that domain without their permission. It's given us name server information, so these are the DNS servers that NSLookup would query, and it's given us information about where this company, in this case Google, is registered. And if we open up our web browser, we should be able to see that going to the WHOIS lookup tool actually on the web browser gives us pretty much the exact same information. So if you just let me adjust this, let me go to Google. Yeah, there we go. So you can see that the power of this little script can give us the exact same information that we would find on the web application itself, which is going to be really handy if you're in a bit of a pinch and you've only got the CLI available to you. Other than that, it's a really cool little project for learning the socket library in Python as well. All right, that's all for today. If you've enjoyed it and you're still around, thank you very much for making it to the end, and I will see you in the next one.